All right, there we go. So we're just gonna pick off where we left yesterday. Do you remember what we were doing yesterday?
IROC and AROC.
Right. Are you a big fan of IROC and AROC?
Not yet.
Not yet. Okay. Let's change that. All right. We're just gonna hop in and let's see where life takes us. All right, yada, yada, yada. We don't really care about the context, not yet anyways. But someone's learning a new language. And this is a number of words, I guess, vocabulary terms. How many terms are learned between t equals 2 and t equals 3? What do you think? How do you approach this question?
Do you just plug in 2 and 3 as T?
So you're saying we should find the IROC, right? That's what you're saying? Or
Do you use IROC if it's like specific?
So what do we do for A? So you're saying IROC, right? So for A, do we like that? Question A is not actually asking you for the rate of change, right? They're just asking for the terms are learned. So they basically only want, for part A, all they want is n of 3 minus n of 2. They're not asking you for the rate of change or the slope or anything like that. They're asking you the difference between the number of words at time 3 and the number of words at time 2. Does that make sense?
Mm-hmm.
So how do we find n3? Well, to find n3, you're just going to plug t as 3, no? Up here, look at this. To find n3, we're just plug t as 3. So we can even do this individually if you would like. N3 would just be 20 times 3 minus 3 squared, 60 minus 9, 51. N2 would simply be 20 times 2 minus 2 squared. What is that? Quick maths, what is that? Twenty times 2 minus 2 squared.
36.
Right. Now what?
You subtract.
So what does that give as a final answer?
15.
Yes. So between time 3 and time 2, it's going to be 15, right?
Mm-hmm.
So 15 new words were learned. What about B? What is the rate in terms of per hour at which the student is learning at time equals 2? So what is B asking us? Well, they've given us one time, right? T equals 2 hours.
Mm-hmm.
See this? T equals 2 hours. This means what? IROC or IROC?
IROC.
Right, IROC. And IROC has the formula of this: f of x plus h minus f of x all over h, and then the limit as h goes to 0. That is the IROC formula, right? In this question, we need to first find n of x or whatever the x value they've given us, the time, that's 2. So n of 2, I think we had this before, is 36. Now, how do we find n of t plus h? Or t is 2, so we know what that is. Let's say n of 2 plus h.
Does the H just stay the same?
H is just gonna, yeah, H is gonna stay as H. So look at this t plus H, it goes in there as whatever's in this bracket will replace all the t's. So right now we have 2 plus h in the bracket. So that is simply going to replace the t. So you get something like this, 2 plus h minus 2 plus h squared. Okay. The first bracket is pretty easy to open. You get 40 plus 2h. What about the second bracket?
Is it 4 plus 2h plus h squared?
Close. It's gonna be so a squared plus 2ab plus b squared. Yeah, I think that you're actually right. Or you said 2h, but it should be 4h. So it'll be minus 4 plus 2 times h, 4h, plus h squared, like that. And whenever you have a negative sign outside, that means all the signs inside are gonna flip. So you get 40 plus 2h minus 4 minus 4h minus h squared. Okay? Does this make sense?
Yes.
You? And this is the hardest part, right? Definitely the hardest part, unless they give you a square root function. Even then, that's not as hard as this one. The hardest part is just finding what f of x plus h is. And now here, we can group up the like terms. 40 minus 4 is 36, plus 2h minus 4 is minus 2h, minus h squared, like that. And now we're simply going to use the formula. So it is going to be the limit. And again, you can ignore this. Just remember that, well, don't ignore it, but you can just robot it, like become a robot, just write it. The h is going to become 0 once they cancel out. This is just a notation. And then you have n of 2 plus h, which is 36 minus 2h minus h squared, minus n of 2, because f of x is n of 2 for us. That's going to be 36 all over h. 36 and 36 cancels out, right? Then you get limit as h approaches 0. What do we do next? We've canceled out the 36s. What's the next step? No? Once the 36s cancel out, you just pull out an h. Because the goal is ultimately to kill this h off, right? So what we do next is we're going to pull out an h in the numerator, or just GCF out whatever you can. In this case, you can just pull out an h. You'll be left with minus 2 minus h over h, right? Like that. H gone. Once h's are gone, this is going to be gone, and every other h that's remaining becomes a 0. So you're left with minus 2 minus 0. That's going to be minus 2. I'll give you 10 points if you can tell me what the units are. Again, units will be rise over run. So think of what's the y value and think what's the x value. What is a unit? Our y value, number of words, right? Or vocabulary terms, whatever. That's our y value, the number of terms. And on the x value, what's our x value? Time is in hours. There we go. All right. In And that's it. Easy as that. Cool. That's it, I guess, for that. It is not that difficult. This one's gonna be trickier. Same type of question. What are they? What do we need to find? IROC, IROC, or just something, a random Y value?
You use IROC?
Yeah, you use IROC. So to use IROC, we need to first find T of X or F of X, which in this case is T of 3, right? This part is easy, 60 over 3 plus 2. That'll be 60 over 5, that's a 12. What's the other thing that we need to find? No? We found f of x, right? Look at the formula. F of x plus h minus f of x all over h. We just found this. F of x in this question, well, f, the function is called t, and the x value they want is 3. So we found f of x. We need to next.
So now you find f of x plus h.
Yeah, f of x plus h, which means t of 3 plus h, right? The h is always going to be h, regardless of what the functions are. So again, wherever you see an h, you're going to replace, or whatever the variable is, right? This h has nothing to do with this h, by the way. I don't know why they called it h here, but wherever you see this variable, you're going to replace that with what you have in the bracket. So it'll just be 60 over 3 plus h plus 2. That'll be 60 over 5 plus h, like that. Okay, and now we're going to use this formula. So it says limit as h goes to 0, 60 over 5 plus h minus 12 all over h. What do you think we do next? Well, we need to kill off this h right now. It doesn't look like it's killable, right?
No.
Let's just try and work our way through this. We're just going to take the LCD here and just hope things cancel out, and they will. They always do. So limit h approaches 0. The common denominator between the two numerators is 5 plus h, right? So you don't have to touch the first guy, but then the second guy, you need to multiply this by what? This guy is right now is lacking 5 plus h, right? Like that. So we multiply 12 with 5 plus h on the top and 5 plus h on the bottom. Why? Because we're trying to clean it up. We're trying to find the LCD, and the 60s will cancel out, as you'll see here. 12 times 5 minus 12 times 5 is minus 60. Minus 12 times h is minus 12h. Now they both have the same denominators of 5 plus h. Yeah, like that. Boom. So 60, 60 gone. Now we have a triple level. We have 3 levels, level 1, level 2, level 3, like it's a triple fraction. When this happens, either the h goes to the second level or the h goes to the third level. The way you want to think about this is this. If you have a over b over c, right? A over, which is the case here, a over b, a fraction on the top, all over another number on the bottom. This is the same thing as saying a over b divided by c, right? Whenever you have a division sign when you're dealing with fractions, you just turn it into a multiplication sign and you flip it upside down. So anytime you see 3 levels in this form, a over b all over c, the c goes to the denominator, the second level, okay? So you get limit as h approaches 0 of negative 12h all over, now this h goes up here, h times 5 plus h, like that. Now, do the h's cancel out? Could we cancel this h and this h?
Yes.
Yeah, you can. So it'll simply be limit as h approaches 0 of minus 12 over 5 plus h. And now we've killed off this guy, h. Every other h is a 0, so you can ignore this. You can also ignore this plus h is just plus 0. And there we go, that's the answer, negative 12 over 5. What are the units? Look at the question. What's our y value and what is our x value? Is Celsius our x value or dependent or independent? You can even think about it that way. Which one is dependent, temperature or height?
Is temperature y?
Temperature is indeed y. So minus 12 degrees Celsius divided by, because the rise over run, y is the rise, right? The y value is rise. So degrees Celsius on the top, and on the bottom we have kilometers. The height is in kilometers. So there we go. Minus 12 over 5 degrees per kilometer. What does that mean? Well, it means for every kilometer that you go up into the sky, yeah, the temperature drops by 12 over 5 degrees Celsius. So that's about 2.4 degrees Celsius. Okay. So for every time, that's why if like if you've been on a plane, I'm sure you have, outside the plane, the temperature is very cold. So that's why you have to be kind of careful. I mean, no one really skydives from that position, but it's usually lower. But we have actually seen someone skydive from space, but he was wearing a lot of like astronaut levels of gear just to survive the cold temperatures up there. Okay, so it gets quite
Did he
cold.
just like fall to Earth all the way from there?
Yeah, he just literally fell to Earth all the way from there. He opened the parachute, I think, yeah. He had an oxygen supply, he had everything.
He didn't die?
Oh, he had a parachute, so he opened it and yeah, he landed. Here,
Oh,
wait. Yeah, it was not. Let me see if I can find it. Here, we can quickly just like look at what's going on here. So boom, boom. So look at this. This is him up, right? There's the Earth, planet Earth, Mother Earth, I guess. And then he's gonna take a dive. And he's off. He's literally in space. You see that? So over there, the temperature is like very, very, very cold. And I'll tell you why that is as well. Because the sun is out there, right? We should all be getting the same thing. And then he opened the parachute, and then he just lands safely. It was very chill actually. Okay, here, brainstorming time. So the sun is here, right? This is planet. The guy was here. How come it's cold up here, but hot down here? Because the sun is about equally far from both the places. It's not like the sun is further away. What do you think is happening? Any ideas whatsoever? I'll give you two explanations, okay? When you think about Earth, this is Earth. We live up here, right?
Is it because of the core?
Yeah, the core is hot, right? The core is really hot. That's point number one. So it's definitely gonna be hotter here because of the core. There's like, we have a mini sun inside the planet, and it's definitely that this guy is way far away from the core. That's reason number one. Reason number 2 is a little bit more interesting. It's because this is our Earth, right? Let's say this is space up here. Let's say we live here. Okay, we live here. What happens is up a certain kilometer, I think it's about 100 kilometers ish, there is a layer in the stratosphere called the ozone layer. Okay, have you heard of this? Ozone layer, denoted by O3. It forms by when oxygen reacts with its own molecule. Then you get in a certain conditions you form ozone. O3 is the chemical symbol. So what ozone does is that the sun actually emits all kinds of rays. It's not just heat. The sun emits UVA, UVB, ultraviolet. These are called all UVC, all types of these types of rays. But some of them can be damaging to humans and life in general. Okay, like they can give you cancer and whatnot. So what the ozone does is it absorbs some of these rays and it's going to reflect back some of it. Okay, it actually eats up, like when you shine a flashlight onto like a black surface, the surface itself will absorb most of it. It won't reflect anything. A black surface won't reflect anything, but this is a little bit more transparent. It will reflect, absorb some, reflect some, and then the ones that it does absorb, actually, it's going to transmit into the earth. And it acts, this ozone layer, it acts as a greenhouse. So what happens is you see this ray, it bounces in and out. It can't escape because it's a greenhouse. It will let it in, but it won't let it out. And this is what conserves the heat. That's because we have the ozone layer acts as a greenhouse. So now
What would happen if we like didn't have it anymore?
we didn't have ozone, it'll be cold like the moon or Mars. It won't be hot. Basically, life would never form. So this plays a huge role in conserving life as we know it. And now the other issue with this, well, not the issue, moving on from this, is the idea about like global warming, climate change, right? We feel its effect on the surface of the planet, right, with floods and like extreme temperatures. But what those there's something called greenhouse gases. This is basically all the fossil fuel burning gases, right? We have like we have sulfur dioxide, we have carbon dioxide, and there's so many of these, you know them. There's some bad and most of this comes from the fact that we burn fossil fuels. So what this does is when it goes up into the ozone and it reacts with the ozone, right? It is going to split apart. You see this O3 is your ozone. This is some chemistry here, but it is going to split apart that ozone molecule. So what that means in layman's terms is that it'll eat up this, it'll make a hole in the ozone layer. And when that happens, the bad UV rays, it's going to enter the planet. So that's one of the other effects of climate change. It's interesting.
So that's happening, or
that is happening right now, yeah. So we're basically it used to be worse, to be fair, when we first, because back in the day all we burned was coal, right? We didn't really have any other forms of energy. Now we don't burn as much coal, so it is not as bad as it was maybe during the Industrial Revolution or whatever, but it's still pretty bad. You don't know what the worst part about this is? The worst part about this is that the hole isn't where the countries are. The hole is in Antarctica. Due to like pressure
is that
differences.
why, like, the ice is melting and stuff?
The ice is melting because of the climate change in general, because the planet is getting warmer. Yeah, actually this is exactly why the planet is getting warmer, because we're letting more of this in and it's going to bounce around, right? That's one of the key reasons why the planet is getting warm. We're letting more rays into the planet and it's going to bounce around. It'll eventually escape through the same hole, but not before the damage is done, I guess. So that's the idea behind why life exists on Earth. The core is hot, yeah, but most of the heat actually comes from the sun. All right, so this is whatever. Let's move on from this, and we're gonna maybe use some calc for the next question. The shortcut method, that is. Let's look at this. They're asking us to find the tangent, right? And we can do this really quickly. F of x is going to be 2 times 4 minus 7. Do you agree? This is f of -2. And then similarly, we can quickly find f of -2 plus h. Wherever you see an x, whatever the variable, it doesn't matter. You're going to replace that with what's in the bracket. So 2 minus h, like this, minus 7. You open this bracket, you'll get a squared plus 2 times a times b. So that will be minus 4h plus h squared minus 7. So you'll have 8 minus 8h plus 2h squared minus 7. Clean this up, you get 1 minus 8h plus 2h squared. And now they're asking us for IROC, so we're just going to do f of x plus h minus f of x. So 1 minus 8h plus 2h squared minus 1 all over h, right? Like that. So 1 and 1 cancels out. Now what do we do? What do we do next?
You pull out an h.
Yeah. So you'll get, you always pull out a GCF. So negative, which in this case, you could also pull out the 2, but it's all right. You don't have to. Like that, and then h cancels out. That means this is gone. That means that h is 0. So the answer is -8. Okay. Now let's try doing it a different way. We're gonna use the other shortcut way of doing this. If it's a number, right? It's a derivative, y prime, number becomes 0. If it's a number attached to the letter drops. Like that. And then if it's in this form, ax to the power of n, it'll become n times a times x to the power of n minus 1. For example, if it's 3x to the power of 5, it'll be 5 times 3 times x to the power of 4. Using this, can you tell me what's the slope function of 2x squared minus 7?
2 times 2x.
Yeah, so 4x, is that it? That's it, right? Because minus 7 just becomes a 0. Once you have this, all you gotta do is plug the -2 in there. 4 times -2, -8, and you're done. Look at that. Super quick, 2 steps. Whereas the other one, you need to find x plus h, yada yada, and then it's a little bit annoying, the other one. It is for sure annoying. But then that's gonna fail if you're trying to do something like this, it's not gonna work out. Because that thing, the rule there is if you can write x in terms of a power. You see this rule? This is gonna fail in this question because we have multiple x's basically. This is called a rational function. When you have something over something, like something x, whatever, you see there's an x here, there's an x here. That's called a rational function. This rule fails when it comes to this. Actually, it doesn't fail, which I'll show it to you when we get to it. But this rule doesn't work. We need to come up with a new rule. Same thing with other, like for any function, like x squared, x cubed, these are all polynomial functions. So you can use this even square root function because you can write it in terms of x to the power of a power. You can use this. But when it comes to other types of functions, it's going to have its own rule. Okay. So this one, we have to do it old school, unfortunately. So f -1, we're first going to find f of x, and then we're going to find f of x plus h. F of -1 will be 2 times -1 plus 5 all over 5 times -1 minus 1, -2 plus 5 over -5 minus 1. That's 3 over -6. That is -1 over 2. Do you agree?
Mm-hmm.
That's -1 over 2. Okay. Is equals to -1 over 2. Now let's find f of x, which is -1 plus h. Tell me, what do we get? We're trying to find f of -1 plus h.
Do you just plug in -1 plus h for all the x's?
That's exactly what you do. So 2 times -1 plus h plus 5 all over 5 times -1 plus h minus 1. Let's open the bracket on the top. What do we get? If we were to open the bracket, yeah.
-2 plus.
So 2 goes with -1, 2 also goes with h, so it's going to be -2 plus 2h plus 5 all over -5, because 5 goes with -1, but 5 also goes with h, so plus 5h minus 1, like that. And this gives us 2h plus 3 over 5h minus 10. Or I don't know where I got the minus 5 from. It'll be -5 minus 1 minus 6, like that. Okay.
Okay.
That doesn't look very fun, because nothing's going to cancel out. But don't worry, things will cancel out once we clean it up. So f of x plus h, we just found it. It's 2h plus 3 all over 5h minus 6 minus f of x. So this becomes plus 1 over 2 because it's minus minus all over h. How do we clean this up? There's a bunch of things you can do. Whenever you see fractions, make sure to kill the fraction, actually. By, in this case, we are going to take the common denominator between the two numerators. What is the LCD between 5h minus 6 and 2? Here's a tip. If you're unsure of what the LCD is, okay, we can call this LCD, bulletproof tip. You literally just multiply the two denominators. This always works. If there's 3 denominators, you could always multiply all of them. There might be, well, it's technically won't be LCD. Like for example, if you have 4, 3, and 2, if you multiply all of them, you'll get 24, but the LCD is 12, which is why we usually half it. But let's say you don't know it's 12. Let's say you go with 24. This will still give you the same answer. 24 is not the LCD, but it'll still give you the same answer, okay? So here the question was, what's the LCD between 5h minus 6 and 2? Well, you just multiply them together. It's going to be 2 times 5h minus 6. What that means is that the first term is lacking a 2. So we're going to multiply it by a 2 on the top and 2 on the bottom. The second term is lacking 5h plus 6, right? Or minus 6, sorry. So you're going to multiply that on the bottom and on the top, okay? Like here, we would multiply, let's say you didn't know it was 12. You'll multiply this by 3 here, sorry, 8 here, 8 here, not 8, what am I saying, 6, because we need a 24. So 6, 6, this one 8, 8, this one 12, 12. And once you do the math, the answer will be exactly the same. You may need to reduce it once as if you took the LCD of 12, okay? Make sense? Alrighty, open the first bracket in the numerator for me.
Am I supposed to get 3 terms?
When you open this bracket, no, you'll get 2, like this.
4h plus 6.
4h plus 6, that's it. And the other one, you'll get 5h, sorry, we should be multiplying this by 2. So the other one, we will get 10h minus 12, right?
Mm-hmm.
And now they have the same denominators, we can just combine them like this into one denominator. And this is again the same thing as a over b all over c. When you have a triple and a over b over something, the c will go here. We proved this earlier, right? Because it's this,
Mm-hmm.
and then we flip this upside down. The c will go to the second level. That means the h is gonna come down to this level, okay?
Okay.
Now there is an issue actually. Where am I getting 5h minus 6 from? It's 5h minus 1. So 5h minus 1. And then this one will be 6, 2. So negative 4. Right? Like that.
Mm-hmm.
Yeah, I think I messed something up for sure, because these are not lining up. So what should have happened in this step is that the two thingamajigs should have canceled out. You see this 4 and this 6 should have canceled out. I mean, we can always double do it. It's not like a big deal. So negative 1 plus h. So 2 times negative 1 plus h plus 5 all over 5 times negative 1 plus h minus 1. And you'll be doing a lot of debugging, this is called. Like when you see something that doesn't quite work out, and that's going to happen. So we have 2h plus 3 over 5h minus 6. So that part was right. I don't know what happened here because they didn't cancel out. Basically, I know something is wrong because they did not cancel out. So we have 2h plus 3, that's our f of x plus h, minus, and our f of x was 1 over 2. So this is going to become plus 1 over 2. We multiplied this by 5h minus 6, 5h minus 6. We multiplied this by 2. Yeah, I think now it's going to work out. All over h. So we have 4h plus 6 plus, yeah, there we go, 5h minus 6. I don't know what happened there, but it worked out nicely because you see 6 and 6? Something should always cancel out once you clean it up. So again, the h from the very bottom went to the second level, limit as h goes to 0. 6 and 6 gone. Then you have 9h on the top, all over 2 times 5h minus 6 times h. Tell me, can we cancel out the two h's?
Yes.
Yes, you can. H gone, h is gone, this is gone, this goes home, tada, bye-bye. And then this h becomes a 0. So we have 1 over 2 times 5 times 0 minus, or sorry, 9 over minus 6. So this becomes 9 over 2 times negative 6, negative 12. And you can further reduce this into 3 over negative 4. And that's going to be the final answer for this question. Okay.
Uh-huh.
A lot of algebra here. And it's more difficult, obviously, if they give you a rational function like this one. If they just give you like x squared plus 3 like we did the last time, like these guys are easier for sure than these guys. What's even more difficult is the square root one, which there's no question here, but we did it yesterday, like this one. Let's quickly do this as well, and again, the more you do it, the quicker it becomes, right? The only difference here is gonna be that we're gonna have to rationalize the numerator. That's the only difference. So let's use the formula. So we first need to find f of x, which in this case is f of 5. So 5 plus 4. What's the square root of 5 plus 4? No? Square root of 5 plus 4.
Is it just 9 squared or?
Yeah, square root of 9 is just simply a 3, okay?
Okay.
And then we have f of x plus h, which is going to be 5 plus h. Tell me, in this question, what's f of 5 plus h?
Square root of 5 plus h plus 4.
Yeah, by plus h plus 4. So that's just going to become 9 plus h, right?
Mm-hmm.
9 plus h. So now we can use the formula limit as h goes to 0 of f of x plus h. So 9 plus h minus f of x 3 all over h, like that. All right, what's the next step? Well, we need to clean this up. You need to rationalize the numerator. Remember how to rationalize? Rationalize just means you gotta get rid of the square root in the top. To get rid of it, you're gonna have to multiply it by its conjugate. What's the conjugate of the numerator? No? So it works like this, right? The conjugate of, let's say, x, it's just itself, like that. The conjugate of 1 square root, x minus 3, is just itself, x minus 3. But then if you have something like x minus 3 plus 4, the conjugate is still going to be both of these terms, but except the sign in the
Minus
middle,
4.
minus 4, exactly. So using this logic, what's the conjugate of the numerator here?
Square root of 9 plus h plus 3.
Yeah, plus 3. And you always got to flip the sign because that's going to allow us to use the difference of squares. And don't worry about and whatever you multiply it on the top, you have to multiply it on the bottom, like that, okay?
Mm-hmm.
And then this becomes limit as h equals 0. Now again, look at this. We have our a here, 9 plus h. So it becomes a minus b, a plus b is a squared, right? So 9 plus h squared. The squared cancels out with the square root, so you'll simply left with 9 plus h. What about the next term? We're using a difference of squares. I did this bit, a squared, 9 plus h. What's b squared?
Minus 9.
Yeah, minus 9. And all over the denominator, you don't have to worry about it because in the next step, the h will be gone. 9 cancels out, right? 9 minus 9, 0. And now you're simply left with an h on the top. The h also cancels out with this h. And that's the whole goal. The goal is to get rid of the h in the denominator. And now once the h's cancel out, this remaining h becomes a 0, right? And this is also gone. So we're left with 1 on the numerator over square root of 9 plus 3. So that's going to be 1 over 3 plus 3, 1 over 6, final answer.
Okay.
Make sense?
Mm-hmm.
So yeah, if you have a square root, you are going to rationalize it. All right. Now let's move on to something called limits. We were trying to find the limit as h goes to 0 before. But now this is going to be a new subtopic. We're going to find limits of any variable going to any number. Okay.
Mm-hmm.
How do we do this? Well, the step 1, you'll always do this. Limit just means find the value of the function when the x value is whatever. In this case, the x value is 1, yeah?
Mm-hmm.
We're gonna straight up plug 1 in there and see what happens. This is what I like to call, this is not a scientific term, but this is what I plug and chug. You literally just take that number and put it into the function and see what that gives you. It works out about 5% of the time. That's the only issue. It doesn't really work out, but this is always the first thing that you do when you're trying to find a limit. So if you plug 1 in there, you'll get 1 squared, which is 1 on the numerator, minus 1 over 1 minus 1. You get 0 over 0. What's 0 over 0?
It's nothing.
Yeah, it's undefined. So that's the first thing you do, okay? It's undefined, but limits are usually defined. What we just found is the y value when the x value is 1, but we don't want the y value when the x value is exactly 1. We would just want to see what the x value is approaching, okay?
Mm-hmm.
What does that mean? That means we need to do some algebra. Usually algebra will do the trick. So look at the numerator. Can we factor that? Can we do anything with that numerator, x squared minus 1?
You can pull out an x.
No, you cannot pull out an x. In the top, pull out means everything there should have had an x. Only the first term has an x, so you can't really pull out an x. But it's in a certain form. Maybe this is a hint. What form is the numerator in? It is a difference of squares. Because 1 is just 1 squared, right? So how do you factor a difference of squares? What does that become? Well, it's in the form of a squared minus b squared, right? It's going to become a minus b times a plus b. Okay. So what does it become in this case?
X squared plus 1.
No. X plus 1 and x minus 1. Because a squared is x squared, right? A squared is x squared. B squared is 1 squared. So that means a is x and b is 1. So it's going to become x minus 1 times x plus 1. Okay. And again, it's a very simple like factorization. It's not even a man. It's just a straight up a simple difference of squares. Does anything cancel out here? Look at this. Do we have anything common in the numerator and the denominator?
The x minus 1.
Yeah. So we're going to say dot of both of these guys. Okay. Now we're left with limit as x approaches 1 of x minus 1. Now let's plug and chug again. 1 becomes x. So the whole limit becomes 1 minus 1, 0. There we go. The limit does exist. It is a 0. Cool. What that means is this. Graphically, if you were to graph this out, it'll look something like this. Okay. And if you look, actually, I don't know if we've talked about this. I think we have actually, for sure we have. The reason that we were getting a 0 over 0 before was if you were to graph this out, you'll get a hole in the graph when x is exactly 1. So the y value when x is exactly 1 does not exist, okay? But limit is not asking for the y value exactly there. Look around it. What's the y value? Well, it's 0. It's very close. I mean, it's literally on the x-axis, right? So what that means is if you go to x equals 1 from down here, you're gonna get to like negative 0.00001 on the y value. If you go at it from the top, you're gonna get like positive 0.0001 from the top. That means when you're going to 1 in general, you're approaching 0, okay? The y value is not 0, we're approaching 0, and that's the limit. It does exist. To find it, usually you have to do some algebra. All right, let's look at this. Now this has a bunch of different things going on, in fact. It has multiple pieces. You see there's one piece, depending on what the x value is, this graph will look different. Like maybe from here to here, we have a quadratic graph, and then the x value is different. And let's say we have like a 0 slope linear function, and then we have another slope, positive slope linear function. This is called a piecewise function because it's made from a bunch of different pieces, okay? So it says graph this. All right, how do we go about graphing this? I'm not looking forward to graphing that square root function though, because it's not going to be very precise. But anyways, let's work at this one thing at a time. Let's look at the first line, x minus 1. X minus 1 looks like this, okay? Y-intercept is minus 1, slope is positive 1, right? For everyone, yeah. 1 and minus 1. This right here is the graph of x minus 1. Cool? Now look at where that function exists. It's gonna exist only to the left of 1. So what do we do here? So we know our function looks like this, -1 and 1, and it is gonna definitely exist over here, but at exactly 1, that does not exist because it says strictly less than, okay? So that means this linear line is going to be something called exclusive, open circle. At exactly 1, there is an open circle. So that's the first part of the graph. Second part, when the x value is 1, the y value is exactly 1. Is this inclusive or exclusive?
Inclusive.
Yeah, because equals means it's inclusive, so there we go. When the x value is 1, the y value is exactly 1. And then from here, we have a different function, 2 plus root x minus 1. Let me just see what this looks like without having to graph this. This is a square root function root x. Minus 1 means it goes to the right by 1 unit. So it'll look like this. And then we did this a long time ago when we were doing transformations, AKDC stuff. The 2 plus means it's going to go up 2 units, okay? So 1, 2. So 1 and 2. So that function there is going to look like this. Is it inclusive or exclusive? Look at the sign.
Exclusive.
Yeah, so it's just going to be an open circle there, and it's going to look like this. We don't have to be very precise for the third one, okay?
Okay.
Now, this one wants us to find the limit when x value is 1, right? Alrighty. If you look at the graph, it looks very weird. It's not like the last one that we did, like this one. If we came at it from both sides, the answer was 0, right? So we need to do the same thing. We need to look at it from to the left of what we're interested in, to the left of 1, I guess, like 0.99-ish. And we also need to look at it from the right side of 1, so 1.01, okay? If you look at it from the left side, what y value is it approaching? What's the y value here?
0.
0, exactly. If we approach it from the right side, so we're looking at 1.01, right? Right side, I mean 1.0. What value are we approaching?
2.
2, right? Right side is 2. If you want the notation, this is what it looks like. Limit as x goes to 1 minus means it's the left side. 1 not minus 1. We're not saying minus 1. We're saying 1 to the power of a minus sign. That means the limit to the left side, okay?
Okay.
Same thing, right side means limit. As you can imagine, it's going to be x to the power of plus sign. That means limit as x goes to 1 from the right, or from above 1, 1.01. We're getting conflicting answers here, right? In this question, we got 0, no matter what we do, which direction we came from. But here from the left, we're getting a 0. From the right, we're getting a 2. Yeah? Conflicting answers means the limit does not exist. It has to be the same from both directions. And that's the idea behind limits. It's funny because we know at exactly 1, the function exists, it's 1. But this is not the limit. This is the y value when the x value is 1. Limit means when you're approaching it from both directions, okay? You gotta take, the left side into account, the right side into account as well. Did they give an answer for this? Yeah, they say it does not exist. Yeah, that's the thing. Because we got conflicting answers from both directions, right? Conflicting answers from both directions. Like this example would make it a little bit clear. Again, the graph is a piecewise function. We don't really care about what the equation is. The first question is asking us -2 plus the limit, right? So we're going to go to -2, and plus means from the right side of -2, okay? Like up here. What's the y value that it's approaching?
0.
0, yeah. So the answer to A is 0. What about 2 minus? 2 minus means, well, we need to go to the x value of 2. 2 minus means like 1.99. So we got to look at it from up here. What's the value?
2.
2. What about 2 plus? That means now we need to look at it from the right side of 2. What is it approaching?
-1.
-1. So a question for you. What is the limit at exactly 2? From the left side, we have +2. From the right side, we have -1. So what's the limit at exactly 2? Conflicting results from the left and right side. Limit does not exist. D and E. And you're done.
Okay.
Does that kind of make sense?
Mm-hmm.
Just got to look at it from, you got to basically squeeze it from both directions. And that's how you find limits. Here's something that we will probably, I don't know, like we've done a lot of like advanced stuff. It's not super advanced, but I'm gonna let you in with a little, leave you with a little motivation for the week. We've seen limits from 2 directions because we're dealing with X and Y plane, right? There's an X axis, there's a Y axis. But in real life, there's gonna be multiple axes, right? It's gonna be 3-dimensional usually. You got to look at it. It's weird to find a limit in 3D though. To find a limit in 3D, you got to look at it from all directions, not just 3 directions. You got to look at it from all directions because there's an infinite number of ways a line could meet that point, right? Look at this. When it's 3D, you got to look at it from all directions. Obviously, no one is going to look at it from like 20,000 directions. That's why we invent like little tricks and theorems in math, but that's the idea. In 3D, things get a little bit more weird, especially mathematically. 2D is fun though. 2D it's good to be 2-dimensional, not as a person, but when you're trying to do math. But anyways, let's call it a day for there.
All right. Thank you.
Yeah.